If we want to determine if something is linear versus nonlinear, we have to look for a constant rate of change. That's our ticket, okay? If it is not linear, it will not have a constant rate of change. Sorry. All right, so when we look at this on a graph, it looks like a straight line. So on a graph, as long as the X and Y axis is set up properly, it will look like a straight line. In an equation, in order for it to be linear, the equation will be set up in this format: y equals mx plus b, something like, okay, I have, let's talk about the money in my account. I have $100 in my account right now, and then every week I add $20. So there it is, 100 plus 20t. Here is our constant rate of change of 20, and that 100 is my starting value. So the other place that you can see linearity is in a table. And if the table so kindly decides to count its x's by 1 and starts with 100 and then goes to 120, 140, 160, 180, then you can see it's going up by 20 each time here. And that's perfect. However, sometimes the tables will try to trick you. So let's say I have a table like this, and this is counting my money earned. I'm sorry, this X will be counting the time. So I start off with 100 in my bank account. After 1 week, I have 120. After 3 weeks, I have 140, 160, 180, 200. Okay, this is great because I can see that this is going at a constant on the Y, adding 20 each time. However, the problem with this is that your X is not going at a constant rate. So if you were to extend this table out to 0, 1, 2, 3, 4, 5, 6, 7, and 8, and have $100 to start, after 1 week, 120, at week 3, 140, at week 5, 160, at week 7, 180, and at week 8, 200. You can see here that this increases by $20 in the first week, but then it takes 2 weeks to increase by $20, another 2 weeks to increase by $20, another 2 weeks to increase by $20, and then in 1 week, it increases by $20. So you need to extend the table out in order to determine if the X's are not counting by ones, in order to determine if it is a linear relationship. Additionally, sometimes it will not look linear because of the way that the X's are counting. 0, 1, 3, 5, 6, but then it will be linear. So let's say we start with 0 and then we go to 5, 15, 25, 30. So when you first look at this table, you might think, oh, okay, well that goes up by 5, and then it goes up by 10, and then 10 again. Oops, that was supposed to be 30. I said it, I just didn't write it. And then it goes up by 5, and you might say, oh, these numbers are all different. It's not a constant rate of change. But what you want to do is extend the table out. X, Y will go 0, 1, 2, 3, 4, 5, and then 6, 0, 0, 1, 5, 3, 15, 5, 25, 6, 30. So now I can see that this has a constant rate of, that this increases by 5. And then in 2 jumps, I increase by 10. So if I increase by 5, that would give me 10 here, and then 5 again is 15. So I'm going to continue this. Another 5 would be 20 to 25 and to 30. So this, in fact, is increasing at a constant rate of 5, even though you might not have seen it in the original table. So please make sure you're extending your tables if you're determining linearity.